Hi guys, welcome back to another video. So in this video, we'll be solving this problem, longest palindromic substring. It's a medium level problem. So let's see the problem statement. Given a string S, return the length of the longest palindromic substring. Okay. And n is given, n is less than equals to 1000. Okay. So we can apply O of n square. So let's see the sample. We're given this string mac, taco, tag, whatever. So taco cat in the middle is the longest palindromic substring and it is of length 7. Okay, so let's see how we can solve this. So we are given this sample. We are given this sample. So the first way in which we can solve this is a very brute force approach. What we can do, we can store we can check every substring in this string that if it is palindrome or not. If it is palindrome, then we can check if it's the length of this substring is max or not. If it's max, then we can store it in our answer. So this is a simple brute force. We just have to check for every substring if it's palindrome or not. So its time complexity is, I guess, close to O of n square or O of n cube, I guess. Its time will be depending upon the implementation. But it is not a good way like we are storing a substring and then we are checking if it's palindrome or not. So it is not an efficient way to check. An efficient way to check is what we can do is we will start a loop from here, from the first index, not zero, from the first index, and we will check and we will apply a second loop, and in that loop we will take two pointers, j at the left and k at the right, and we will apply a for loop where j will go to the last character and k will go to j will go till the first character and k will go till the last character. So we will check if the character at the jth index, this character is equals to this character. If they both are equal, then j will move to one step to the left and k will move one step to the right, and we will increment our answer. Suppose initially there was a single character, so temp was 1. Then if the jth and the kth character both are equal, so we'll increment 2 plus 2. And similarly we will take j to the left, k to the right, and this will go on until we find a case where jth character is not equals to kth character, or j reach to the first character, or k reach to the last character. So we'll terminate the loop and we will store the max, like we will just do this answer equals to max of answer comma temp. If temp will be max, then it will get stored in our answer, else it will remain same. So this is the first way to check for the odd substrings, because we are taking a character at the mid and we are checking two characters, one from the left and one from the right. So we will always be checking for the odd substrings. But how we can check for the even? Let's see. So similarly, let's take, let's erase this and write this. Now for the even, what we can do, we can check if this character is equal to its left character. Like if this character was equal to this character, then we will start our j pointer from here, from the left, from the, like the index is 1, like here index is 1. No, so j will over, let's take another. Suppose our I is here, okay, in this character. So if it's equal, if this character is equal to its leftmost character, sorry, if to the left character, like if it's equal to this, if it's equal to this, then we will take j from here, k from here, and we will check similarly what we were checking for the first For the first approach, in which we were taking j and k, and we were checking if jth character is equals to kth character, and if they are equal, then we will move j to the left and k to the right simultaneously. So this is the way we can check. We will just have to check if the ith character and I minus 1 character, the character at the ith index and character at the I minus 1 index is equal or not. If they are equal, then we will take j to I minus 2 and k to I plus 1, and we will check if they are equal, and similarly j and k will go on until we find a case where jth character is not equals to kth character, and we will terminate. So in this we will start as we got two characters similar, so we will take temp equals to 2 and we will increment to plus 2 plus 2. So in this way we can check if even if we can check for all the even length substring. So this is a way. So the time complexity will be equals to O of n square. And this is the more efficient way, because we are not storing any string. We are just applying two loops and checking checking with the loop only that if the two strings are palindrome or not. A substring is a palindrome or not. So let's see how. So let's code the solution out. So first we will use the method like the brute force one, like storing every substring. So what we can do, if n, we will take some case, if n 1, then we will return 1, and if n is equals to 0, then we will return 0, and then for I we will apply two loops. J is equals to I plus 1, j is less than n, j plus plus. Initially our answer will be 1 because a single character is always a palindrome. So if, then we will take the substring I comma j minus I plus 1. We'll check if, and then we will take string p equals to t. We'll reverse this, and if p is equals to t after reversing, that means it's a palindrome. So we will take this max of answer comma t dot size, and then we will return our answer. So let's run this. What is okay, so let's run it again. So we got accepted, but I think it will barely pass because it's close to of NQ. Oh, okay, we got the success because, and it took 2.1 something of seconds. So, and it's not good. It's not a right solution. It took, it exceeded the time 1 second, so it's not an efficient solution. So let's see how we can solve this in an efficient way. So we will take answer equals to start with 1, and if n is less than equals to 1, then we will return n, and for id I is equals to 0, I will start from 1, I is less than n, I plus plus. If s of I, no, we will apply a second loop. We will take a temp variable equals to 1. We'll check if apply a loop where j will from I minus 1, start from I minus 1, k will be I plus 1. We'll check if j reach to the first character or k reach to the, then we will terminate, and j will go minus minus and k will go plus plus. If s of j is equals to s of k, then we increment our temp to plus 2, else we will break here. So we will store this answer comma temp, and this code was for the to check for odd substring. So this was for the odd substring, and we'll check for even substring. So we'll first check if s of I is equals to s of I minus 1. If this is equal, then we will take another, suppose L equals to 2. and we will apply a loop int, or let's not take same temp equals to 2, and then we will j will be then I minus 2, because we already checked for I and I minus 1, so j will be from I minus 2, k will be same from I plus 1, and same condition less than n, j minus minus comma k plus plus, and if s of j is equals to s of k, then temp plus equals to 2, else we will break, and again we will store the max comma temp, and then we will return our answer. So let's see, let's run this. So we got accepted 7, let's submit, and it will, yeah, and it took only 7 milliseconds, and the previous one took 2.1 seconds, which is, there's a huge difference between the time of two solutions. So this was the most efficient solution for this problem. Okay, so thank you for watching, and I'll see you in the next video.